Hi, in this video we're going to be looking at scatter plots. And so scatter plots are used when you're comparing two different types of data. So in this case, we've got a table here that's comparing the temperature of water at different depths. Okay, so the first question is, what is the independent variable? So in this case, the independent variable is the depth of the water. Because it doesn't depend on the temperature, the depth of the water is just independent, it's at specific levels. Next question is, what is the dependent variable? And the dependent variable is the temperature, because the temperature of the water depends on what depth it was measured at. What we're going to do now is we're going to use this data and we're going to create a scatter plot. So just like I said before, our independent variable, which is the depth of the water, goes on our x-axis, and our independent variable is our temperature, and that goes on our y-axis. So this is being created in Desmos, fantastic program. So first of all, I'm going to click up here and I'm going to add in a table, and I'm going to start typing in the values. So at 100 metres, the temperature of the water was 76, and you can see that's created a point on my scatter plot. So I'm just adding in the remaining data points. Oops, missed one. It should be 52, 48, and the last. And we can see that each one of those data points have been marked on my scatter plot. What we're asked now to do is to describe the relationship in this scatter plot. Now we can see that it's going down from left to right. So as my depth of water increases, my temperature decreases. So I could say that there is a negative relationship. We can also see that it's going down pretty much in a linear way, producing a straight line. Not perfect straight line, but we're looking at a general trend. So we can say that it is a linear relationship. We can also see that it's producing a pretty close to a straight relationship. The points aren't all over the place. And so we can say that there is a pretty strong relationship. In this graph, they're comparing two different types of scatter plots. So if we're looking at the red dots, we can see that they are going up from left to right. So as it's increasing in this direction, it's increasing in our independent variable. And we can see that there's a fairly strong pattern. So we would call that a strong positive relationship. Our orange data points we can see are going down as we go from left to right. So that would be a negative relationship. Here we've got another set of data points. We can see that they're going down from left to right, and they're going down pretty much in a linear relationship. So we would call this a linear, and we would also call it negative. Oops, sorry. Now, sometimes you can actually have outliers. Now, outliers might be just something that doesn't follow the general trend, or it might be an error in measurement or things like that. So let's have a look at the general lot of data. If we're looking at this section here of the data, we can see that overall it's going up from left to right, and they're generally reasonably close together. So we could say that there's a general possible trend. But if we look at these ones in here, it looks like there's no association. But we could say that these ones here that I've circled could be considered outliers. So that if we weren't considering those outliers, we can see that for the rest of the data set, there's a fairly good positive trend. So outlier, outlier, outlier. Not all scatter plots are going to produce a straight line or a linear one. We might get ones, and I'll just sort of make up some data points and say that I've got some that are increasing up to a point, and then they're decreasing. So you can see here that with these data points that I've put in, you can see a trend that it's going up and then down. So it's not a linear relationship, but we can still see that there's a relationship. So this is different to having no association. I might put in an outlier over here, and I might put an outlier down here. But all of the rest of my data points are following a general relationship. This is different to having no association. No association is when the points just are random. I can't find any sort of pattern that they're following. That basically, you can see here that sometimes there's a relationship going this way, but then this one is increases, that's lower. So we can say that that is a no association. In this graph, they're comparing the height of a runner and the weight of the runner. So they're saying the weight of the runner is dependent on the height of the runner. So our independent variable, which is on our x-axis, is the height, and our dependent variable, which is on our y-axis, is the weight. Now, we can see that there's a general trend. It's not as strong as other ones, but we can still see that as we're going from left to right, it's increasing. But it's asking, are there any points that you could find surprising? And I would say it's this one down here. Because if I'm looking at it, that's 40 years. Sorry, not 40 years. 40 inches, I suppose, or however high that is. And this would be the weight. And so if that's 20, that's about 5 kilograms. So basically, I'm not quite sure what sort of cross-country runner this would be. It would be a very, very tiny person, or maybe someone included their hat. So regardless of this point down here, which seems a bit strange, but is the association shown in scatter plot positive or negative? Because it's going up from left to right, that as the height of the runner increases, the weight of the runner increases. So we would say that it is a positive association. And the next question is saying, would a linear function be a good model for this data? And I would say yes, that overall we can see that they're generally going up in a straight line. They're scattered around a point, so it's not as strong as our previous relationship, but we can say that it is a linear relationship. Now, in this example, it's the other way. They're looking at the level of interest in a ride for the waiting time in minutes. So we can see that, if you have to wait 24 minutes for a ride, you're not that interested in doing it. Okay. Now, in this graph, it's looking at students' grades in math and their grades in choir. Not a subject that we have at Gympie High, but that's fine. So if we're looking at these ones here, you can see that there is no association. Okay. In this graph, we're looking at temperature of degrees in Fahrenheit and degrees in Celsius because they're both temperatures of the same thing. So we can see that this one is directly in exactly a straight line, so it's certainly linear, it's definitely strong, and it's also positive. So as the temperature is measured in Fahrenheit, it increases, it also increases in degrees. Now, this one graph, at first glance, it looks like it might have no association because we've got some points that are high in time and low in height, but let's have a look at what this is. This is a bottle rocket height versus time. So if we're firing a bottle rocket, it's going to go up and then it's going to come down again. So we can see that there is a relationship. It's going up and then it's coming back down. So yes, there is a relationship. It is just non-linear. Does it form a certain pattern? I would say that it is a strong relationship. Can we say that it's positive or negative? Well, no, because as it's going up, there's a positive relationship, but as it's coming down, there's a negative relationship. So you wouldn't say either positive or negative. Okay, so that's it for our introduction on scatter plots. Thank you.